Hello, you absolute legends. This is for the acid-base titration lab, part 1, where our goal is to determine the molarity of the base. You'll use an instrument in this lab called a burette, and a burette can be hooked up to the ring stand using a clamp that looks like this, and here is the burette in its full glory. Inside the burette for part A and B will be placed the base solution up top, and for part A we will have an acid, oxalic acid in this case, down here in the bottom, and also some drops of indicator. Let's talk about how to set up our first quick and dirty run. For part A, we will weigh out about 0.1 grams of oxalic acid. We want to just make sure to record this number exactly what it is. There we go. We're going to record that number in our notebook. We're going to put our oxalic acid sample inside of a beaker or a flask and just fill it up with water. We want to make sure that all the solid is dissolved. So we're going to stir this and crush up crystals until all the crystals are dissolved. All of our crystals are dissolved for part A, the oxalic acid, and we're going to add 3 to 5 drops of phenolphthalein indicator. Up in our burette, we have loaded it with sodium hydroxide base, and we're going to record the initial volume to 2 decimal places. Our first run is going to be a quick and dirty run, meaning that we're going to run through it fast to get a ballpark for our numbers. We are going to record the initial volume, and then we're going to open this up. You see the pink already forming, but it's disappearing quickly. See how fast I'm going? This is my quick and dirty run. All right, looks like the pink is persisting. White underneath helps a lot. Okay, so for my quick and dirty run, the idea is to get a ballpark of how much base is used here. And the reaction is over when the pink is intense, vibrant, and persists for a minute. But we want that is done there. That is done. Okay, so I definitely overshot it, but now I have a ballpark. Specifically, I started up here, and I used about that much volume of the base in my quick and dirty run. You just saw the setup and execution of the first quick and dirty run. And the first quick and dirty run is for you to get an idea of the volume that you'll be using for your trials 1, 2, and 3. Calculations. The goal for the lab is to determine the molarity of the base present. We need 2 numbers to calculate: the moles in the base and also the volume of the base. The volume is the easiest one to kind of use here. To get the volume, we use the numbers we get directly off of the burette. They're in milliliters, but we can convert them there, okay? The second number we need is the moles of base that is present. Now we weighed out the acid in grams. We will indirectly measure the base because we know the ratio of acid to base in the balanced chemical reaction. The ratio is 2 to 1. For every 1 acid that's present, 2 bases are consumed. So when you saw the pink color of the acid-base indicator, that means that these are in ratio to each other, twice as many moles of base. So we start with our grams of acid that we weighed out. This is what I did for my trial. Every trial will have a different bit of mass right here. We want to convert this to moles. So we'll look it up from the periodic table, the molecular weight of this right here. 24, 25, 26, plus 64, 64, 74, 84, 90. It's about 90 grams per mole. The moles of acid to base is in this ratio. The answer to this scaffold here that you will do for every single trial will tell you the moles of base that was dispensed from the burette. The answer to this scaffold goes in the numerator. The answer to this subtraction goes in the denominator. And that is how you calculate the molarity of a base. I hope this helps. Thank you.